We present stereo layers, a method for novel view synthesis from a stereo pair. Our model is trained end-to-end to reconstruct the scene with a set of semi-transparent mesh layers. It was shown previously that with two or more input images, one can represent a scene as a regularly spaced set of frontoparallel rigid planes. Each plane is equipped with a texture consisting of RGB color and opacity channel. Such a representation is called a multiplane image or MPI. Even though MPI estimation is feasible, the number of rigid planes required to plausibly approximate the scene is relatively large. Prior methods usually use 32 to 128 planes. The main reason is the difficulty of reproducing curved objects using planar geometry. It seems reasonable to use the coalesced planes to handle an object like this red rod sign. Several existing works have addressed this problem with the post-processing procedures. It has been proposed to manually merge the estimated multiplane structure using some heuristics. The result represents the scene as a stack of semi-transparent mesh layers, where the number of layers is significantly less than the number of planes. Unfortunately, the procedure can introduce additional discontinuities during merging if the heuristic does not work optimally. In contrast, our method initially estimates the proxy geometry as several non-rigid layers. Afterward, the color and opacity channels for the predicted layers are recovered. Both steps are implemented with deep convolutional networks. These networks are trained together with photometric supervision in an end-to-end manner on a dataset of videos. The obvious benefit of our method is that we produce an adaptive multilayer representation for any scene. This allows for using just 4 layers for a scene. It is important to know that the quality of novel views is no worse than with a set of rigid planes. However, our method still has some weak points inherited from the baseline method. Among them, the input stereo pair is processed asymmetrically, and the cost of extending our approach for more than 2 given views is high. Despite this, our model produced strong results in the stereo magnification task, according to the formal metrics and human preference score. Alongside the new method, we also propose a new dataset of videos called SWORD for training models of novel view synthesis. Compared to the popular real estate 10K dataset, our dataset contains more large central objects with more occluded parts. In this slide, we show the results of our stereo layers model on various scenes from the contributed dataset. Here, you can see a comparison of our method to the most closely related StereoMax system that uses a dense proxy of 32 rigid planes, as well as to a more recent IBRNet method based on the estimation of the radiance fields. Despite using fewer layers, our model provides sharper images with fewer artifacts. These results were obtained for the popular LLFF benchmark. For a fair comparison, we consider 2 modifications of the StereoMag baseline model. StereoMag 8 employs 8 rigid planes to build the proxy geometry and exhibits some artifacts. StereoMag P4 takes the results of the original StereoMag with 32 planes and combines those planes into 4 non-planar semi-transparent layers, which results in a representation quite similar to ours. StereoMag P4 uses a heuristic-based merging procedure, which is not trained end-to-end with the neural network. As may be seen, it produces worsened results with noticeable blueness. Additionally, we demonstrate a comparison with StereoMag on the well-known real estate 10K dataset. In this slide, we compare 2 versions of our model. One was trained on our proposed dataset and the other one on the real estate 10K data. Here we show some failure cases. They can be attributed to a combination of the photometric complexity of the scene and an unlucky random choice of the input stereo pair. We conclude our presentation by showing the stereo magnification by a factor of 3 obtained with our method. Thank you for listening. We have put all information on our webpage as well as a link to the new dataset.